All right, so we're going to start chapter 2, which is basically all about descriptive statistics. And chapter 2 is really divided into two parts. The first two parts, sections, we are going to talk, which is the first part, we are going to talk about graphical displays and how to organize data. And then the second part, which is sections 3 through 5 in the book, are about numerical ways to describe your data, numerical characteristics. So first of all, let's talk about just different types of charts and graphs. And I just want to be clear, we're going to talk about several different types of charts and graphs. But there are a ton of different types of charts and graphs, pretty much an infinite number of kinds. So we're just going to talk about some basic ways to display data and some popular ways to display data. But that shouldn't restrict you. So if you ever study this further, and you may even know of some other types of charts and graphs that exist. But one chart that a lot of other charts are based on is something called a frequency distribution. And a frequency distribution is a table that shows classes or intervals of data entries with the count or number of entries in each class. And the frequency f is what is the symbol we use to denote frequency of a class is the number of data entries in the class. So when you make your project, what you're going to do is you are going to make a frequency distribution with the data that you collected. And a frequency distribution is always made using quantitative data, which is why for quantitative data in your project, that's the type of data it had to be. Okay, so how do we make a frequency distribution? Well, first of all, these guidelines are outlined on page 40 of your book. I would highly advise you read pages 40 and read the guidelines. Go through an example in the book. And in fact, if you just go through all of section 2.1 and read from the book and then watch this, that might be beneficial to you. Or watch this first and then just go through it if you want to see another example. All right, so first thing we do is we decide on the number of classes. Now this is something that can be arbitrary. Two people can have the same data set, and one person says, I want 10 classes, the other person can say, I want 7. There's really no wrong or right way to do this. You just want to make sure you have a good number of classes so you see the shape of the data, and we'll talk more about that later. But basically, I'll write here, your minimum, I would say, would be 5 classes. Sometimes you can stretch it to 4, but really you don't want anything less than 5 classes. Okay, and then you don't want too many classes either. Generally, if you have more than the number of data points, or so for example, if you have a data set of 50 data points, you don't want 50 classes because then every data point would have its own class, and that'd be kind of silly. So generally you want to somewhere a happy medium so you can get a good shape of your data. Okay, so we're going to find the class width, which after you decide on the number of classes is the range divided by the number of classes. Then you find the class limits. We make tallies, and we count the tallies to find the frequency. Okay, and this is very important. The class width is the difference between the lower limits or upper limits between two different consecutive classes, not the difference between the lower and upper limits of the same class. So at this point, let's look at an example on the following page, and I'll show you what I mean. So here we have a data set that lists the reaction times of a sample of 30 adult females to an auditory stimulus, and we want to create a frequency distribution of 8 classes. Now notice that they give us the number of classes here. And generally, if I want you to make one, I will give you the number of classes, because that way everyone should theoretically have the same frequency distribution. However, if you have your own data set, you may want to mess around with this and try a different number of classes to see what would best suit your data set. Okay, so if we look at this data set, we have reaction times listed here, and we want 8 classes. So a frequency distribution has a table, is a table, and notice that our first column is class. And if we go to our steps here, the first step is decide on the number of classes. Well, that's already done for us. But then we find the class width, which is first to find the range divided by the number of classes. And remember, range is maximum minus minimum. So the smallest number in our data set is 291. The largest number in our data set is 514. So we'll take 514, we'll subtract 291, and then we'll divide by the total number of classes, which is 8. And this is 27.875. Because our data set is whole numbers, we're going to round this up to 28. And we always round this up. Okay? And again, this is called the class width. And we always round up. And the reason why is because if we didn't round up, we wouldn't be able to fit all the data points. We need to always round up at this point. So, to finally start making the classes, what we do is we take our lowest value, which is 291, and we add 28, which is our class width, going down, which is 319. And we'll add 28 again, which is 347. And we'll add 28 again, which is 375. And we keep going. $459, $487. Okay? And I just added 28 every time. And that is exactly what this important note says here. It's the difference between the lower limits of 2 different consecutive classes. So notice how when I found the class width, I found the range, divided by 8, rounded up, I found the class width, but I added going down. I did not add 28 and put the 319 here, because this number over here should actually be 318, because this is 1 less than 319. So this should be 346. Again, because that's 1 less than 347. And at this point, you can just add 28 going down this way, or because you already have these numbers, this number is just going to be 1 less than the lower limit of the next class. So this is 374, 402, 430, 458, 486, 514. And there you go. And that's how we come up with the classes. And depending on what book you read, actually, you may encounter different ways to do this and create a frequency distribution. I'm just going to follow the way that this book goes through it. That way we're also all on the same page. But just keep in mind that this is not a one way to do things. There's plenty of ways to display data. There's plenty of different ways to display data and tables and frequency distributions. And this is just one of the ways to do that. Okay, but whenever I ask you to make, or if I ask you to make a frequency distribution, this is how I would expect to see it, just to follow what our text talks about and for consistency purposes. Okay, so this is the classes now, and one thing I would like to point out is that keep in mind the class width is 28, and that's because 28 means that there's 28 numbers in each class. And you might say, well, Mr. Smith, there's not 28 numbers in each class, because if I take 318 and I subtract 291, that's actually 27. Where's the 28th number? Do you know? Well, the 28th number is the 291. You have to include the 291, and we subtracted it away. So keep that in mind, okay? This is why we add 28 going down. If I add 28 going across, there would actually be 29 numbers in each class, not 28. That's why we add 28 going down, okay? It's kind of like when an English teacher asks you to read pages, let's just make it simple, 1 through 10 in your book, okay? And they might say, well, 10 minus 1, that's only 9 pages. No, it's not. It's 10 pages. You have to include the first page, right? So keep that in mind. Keep that in mind. Okay. Erase this part. So now we make tallies. So what we do in the tally column is the tally column is just strictly for organizational purposes. So the easiest way to do this is to go through the data set once. So for example, I see 507. So I make a tally where there's 507. Actually, gotta zoom out so I can see this whole thing here. Here we go. So 507, I made a tally. 389, tally. 305, tally. 291, tally. 336, tally. 310, tally. And I keep going and I make all the tallies. So I think you get the idea. In your final product, if you ever make one of these in a final report or for your project, I don't need to see the tally column, because the frequency column is the total of the tallies, which is really what we care about. So when you're all done with this, this is what the frequencies are. There's 5 data values in between 291 and 318. There's 4 between 319 and 346. There's 3 between 347 and 374. And just to keep going, there's 5 and 6 and 4 and 1 and 2. And that's the hardest part really right there, is making the classes and finding the frequencies. Okay? So if you have any questions about this process, feel free to email me. But yeah, that's basically how you do it. Or you can look at another example from the book. But we're not done. So we still have 2 more, or actually 3 more columns. The other columns are the midpoint column, the relative frequency column, and the cumulative frequency column. And I tell you how to calculate these right here. So midpoint is the lower limit plus the upper limit divided by 2. Relative frequency is the class frequency, F, divided by the sample size, N. And cumulative frequency is basically a running total of the frequencies. And I'll show you what that means in the example. So the midpoint, to get the midpoint, you basically add them together, add the lower limits, upper limit together, and divide by 2. So if I add 291 plus 318 and divide by 2, that gives me the middle, right? Which in this case is 304.5. And we do this going down. 318 plus 346 divided by 2. The middle between those numbers is 332.5. And we can keep going. Now, notice that after you find the first, you don't need to average every single pair of limits together, because you know the class width is 28. And so if I go down, I should only have to add 28 every time. Notice that if I take 304.5 and add 28, I get 332.5. Well, let's add 28 again. That's 360.5. Add 28 again. That's 388.5. And this gives us all the midpoints. So if you're doing this by hand, a good way to check your work is add 28 going down, or whatever the class width is, and then check it. Find the average of these two. If you add 487 and 514 and divide by 2, you're going to get 500.5. All right. Relative frequency is relative because it's relative to the sample size. So in other words, how much of this class, okay, or how much of this sample does this class take up? So it's a percentage or a decimal. So for example, if I take if there's 5 frequencies or 5 data values in between 291 and 318, if I take 5 and divide by the total number of data values, which is my sample size, n, which in this case there's 30 females that we got data points from, that's 5 divided by 30, which is 0.17. So 0.17 of the data, or 17% of the data, is in between 291 and 318. And we do this for all of them. So we take 4, divide by 30. It's 0.13. And we do this for all of them. So 3 divided by 30 is 0.1. 5 divided by 30, we already did that. 6 divided by 30 is 0.2. 4 divided by 30, we already did that one. 1 divided by 30. 2 divided by 30. And I just rounded them all to 1 or 2 decimal places. 1 if it's exact, 2 decimal places though at a minimum, because that's the nearest whole percent. So I would at least go to 2 decimal places there. Good way to check to see if you did this right, add them all up, because the relative frequencies, they should all sum to 1, right? So if you add this whole column, you should get 1. Last is cumulative frequency. Cumulative frequency, you start with the frequency of the first class, which is 5, and it's a running total. So the second class, the cumulative frequency, is the sum of that class frequency and all the classes before it. So 5 plus 4 is 9. Plus 3 is 12. Plus 5 is 17. Plus 6 is 23. Plus 4 is 27. Plus 1 is 28. Plus 2 is 30. And a good way to check, we know we got 30 data points, so the last number here should be the sample size. And 30 is our sample size, right? Because we got 30 in our sample. Got 30 data points in our sample. Okay. And these blanks here, just some terminology or really notation that you should know is if I ever write this symbol, this is a capital sigma, which means sum of. So the sum of the frequencies is equal to n. And the sum of the relative frequencies, f over n, is always 1. Okay? All right, and that's how you make a frequency distribution. So again, I would advise going through at least the other example in the book. I think would be helpful, or as you're going through the Math Excel problems, they go through the same process. Okay, so I'm gonna actually stop the video here, and then I'm gonna finish the notes to talk about the graphs that you make from a frequency distribution. All right, in the next video.